Okay, so for this problem, there are three components. For each component, we're supposed to find the impedances. Okay, so I mean, for each component, we want to find the impedance, and we want to express the impedance in both polar forms and rectangular form. Okay, so first let's look at the resistor. So for this resistor, the resistance is R is equal to 6.8 ohms. We know the impedance for a resistor, ZR, is equal to R, okay, in rectangular form, so which is 6.8 ohm. And in polar form, remember the phase angle for resistor is equal to 0, so it's 6.8 ohm with 0 degree. Okay, that's in polar form. So this is in rectangular form, and this is in polar form. Okay, so all right. So let's look at the inductor. And inductor, we know the impedance for inductor is equal to JXL. Okay, so and XL, we know XL is equal to omega L. So we have omega, we have L. So if you can do the calculation, it's J, omega is 377, which is RAD per second, times inductance is 1.2 H. Okay, so and if you do the calculation, it's equal to J times 452.4 ohms. So this is in rectangular form, and if you want to express this in polar form, it's 452.4 ohms with 90 degree. Okay, so that would be the rectangular form and polar form for this inductor. Okay. All right, so let's look at the capacitor. So for capacitor, we know, say, the impedance can be expressed as negative J XC. Okay, so it's negative J XC. We know XC is equal to 1 over 2 pi FC, and 2 pi f is equal to omega. Okay, but here we have f as the given value, so that's why we choose 2 pi f instead of omega. Okay, so we have negative J times 1 over 2 pi times f is equal to 10k, so 10 times 10 to the power of 3 times C is equal to 0.05 times 10 to the power of negative 6, because it's micro. Micro is negative 6. Okay. All right, so if you calculate this, it will be negative J 318.3 ohms. Okay, so this is in rectangular form, and convert this into polar form, it becomes 318.3 ohms with a negative 90 degrees, because you have a negative J here.